Okay, so the next what we're going to see is Lamport logical clock. This I have implemented from scratch. So let's take a look at it. Um, okay, so first of all, I think we need to discuss what Lamport's logical clock is. So there could be multiple, like it is a logical clock for a distributed system, uh, so that the mm, process, like the resources are not in a deadlock. Yep. Okay, that is the explanation. Because yeah, so it is for scheduling the processes in such a way that there is no deadlock. So even in a distributed system, when there are multiple processors, um, even among that, with a specific timestamp value, based on the timestamp value, the processes will uh, take be executed, except for the parallel ones which are not interrelated. If there is a relation between them, then it has to wait for the previous process to get over. If it is not related, if that is yeah, if there is no relation between two events, between two different processes, then it can happen parallelly. But if there is a relation, then uh, the one of the process will need to wait for the other process to finish the execution. And then only, so according to that, the timestamp value has to be updated. So the timestamp value is the most important thing, and based on that only we are able to demonstrate what is happening here. Okay, so I'm taking in the number of processes and events, like yeah, number of events of each process. So suppose there could be like three processes. First process could have like three events, second process four events, and third process two events. Then okay, we are creating arrays for holding the relationships and the events, and I put origin process, origin event, and the termination process and termination event. And it is related to which process and which event. I took it in that manner and I stored it in the array we created previously. Process and the, like the dimensions of the jagged array is process and the number of events of those corresponding processes. So it changes. Then initial timestamp values I created, like if there are three processes for the first event, it is 1 2 3 initial values. Then if the process 2 has 4 events, it is 1 2 3 4 for the second process. As such I have created. And then now the scheduling part. This was the hardest part to get correct, because it has to be done perfectly, and updating it was a little difficult, or rather quite difficult. So yeah, whenever there's a, I checked, like whenever there's a relation, like for each relation I checked the relations that we took in the uh, arrays before. We created the arrays before and we took the relations. So based on that, uh, I check whether the timestamp value of the previous relation that it is related to, the timestamp value is greater than or lesser than. That is what I checked. So based on that, if it is um, greater than, then the, I mean the term like the origin process origin event and terminator process terminator event. So if the origin is greater than the terminator has to be updated. And if the origin is lesser than the terminator, nothing. It is as it should be. So then, okay, so for this has to be done for both, like if the events are serial, as in the same process, and also when it is related across the processes. So you have to check for both those conditions. And here I'm just displaying the final schedule. Okay, I've already typed it. Okay, fine. Anyway, yeah, I'll execute it. Okay, I'll enter the same. Enter number of processes 4. Number of events in each process 4, 4, 2, 3. Highest number of events 4. Number of relationships. This is the total number of relationships in the entire thing for all the processes. So 3 I'm taking. Okay, 4, 2 is related to okay, hold on, it's stuck. Yeah, is related to 3, 1. 2, 2 is okay, I need to wait. I entered it in the wrong order. I need to start again. I'll go exactly according to the example that I took. But yeah, it should work for anything. I've tried multiple things. 4, 4, 4, 2, 3, 4, 3, 4, 2, 3, 1. 3, 1, 2, 2, 2, 2, 1, 1. Okay. So, wait, actually, to verify this result, it has to be entered. I mean, like it should actually be written on a paper, and you can actually verify it whether that is the actual schedule. So I have already cross-checked this one. So yes, this is the correct schedule that will come at the end of the schedule, like scheduling of the distributed thing according to Lamport's logical clock. Okay, so that is it for Lamport's logical clock.